So what is the objective of this lab?
I put, does the location of stimulus, calf and finger, and or frequency of stimulus affect the sensory threshold?
Yeah, so that's basically it. And she kind of did it in one sentence. You could have also done it in two sentences. How would you say it in two sentences? If you separated kind of the two parts of the objective.
Oh, are you asking me?
Oh, anybody. I was actually hoping somebody else would say something.
So I wrote, is there a relationship between sensory threshold for electrical stimulation of skin and the bodily location of the finger or calf? And then does the frequency of the stimulus have an effect on the sensory threshold for electrical stimulation of skin?
Yeah, so exactly. So, Haley separate, Lily did it all, like, does location and or frequency of stimulus affect threshold? Haley, like, does location affect threshold? Does frequency of stimulus affect threshold? I wanted both of those out there just to make sure people are really clear. There's two questions we're asking. They're both relatively straightforward. Both cases, our dependent variable is the threshold. And now it means our hypothesis will need kind of two predictions, one prediction for each part. So who wants to start? How about a prediction for the body location part? I can also do like this. All right, somebody, or I'm going to just. All right, Tim Hurd.
Somehow I knew that one was coming. All right, so for the first part, I apologize.
It's okay.
So for the first part, I said, in terms of the hypothesis, that I believe that when the stimulus is applied to the back of the calf, it will show a higher sensory threshold in relation to the finger. This is due to the greater sensitivity to touch in the fingers than in the back of the calf.
Yeah, so that's basically it. And the greater sensitivity due to touch is due to what? What does that imply, really?
The amount of receptors.
Yeah, the amount of receptors and kind of neurons right underneath the surface there. Yeah, so that's good. So that's part of what we've got going on is body location versus threshold. And then how about for a prediction for the frequency versus threshold? Reina Barrera Aguilar.
So I put that, hang on, I need to find the exact wording that I used, but I talked about how because of temporal summation, a higher frequency will result in a lower sensory threshold because the stimuli add up and begin building on each other, which will allow it to hit sensory threshold easier.
Yeah, so that makes sense, particularly if you're thinking about, right, there's some threshold where you're actually gonna notice something. If you're just doing a single thing and it's not enough, but if you're doing them in quick succession, then that smaller thing, if they're adding, are actually going to allow you to reach that threshold. So temporal summation would allow you to use a smaller signal if you're repeating it quickly than if you're using a single pulse, in which case you'd have to have a larger magnitude for that in order to notice that. So I think it should feel kind of intuitive if temporal summation makes sense. So that is the lab, and the other things we can talk about, the sources of variability. What are sources of variability with this one?
Individual sensitivity.
Right, so I mean, definitely individual sensitivity, and part of the way we get around that is what we call like that within subject control. We'll do the different conditions with the same person. So maybe I'm more sensitive than this other person, and this other person's more sensitive than me. But for each of those people, we can see like what is my calf compared to my finger like? What is my threshold at 5 hertz compared to my threshold at 25 hertz? So it doesn't matter if overall I'm shifted into the more sensitive or less sensitive. I'll still be able to see the relationship between the independent and dependent variables. And then also we'll look across many subjects and average all of those. So we'll also be able to kind of hopefully take care of the fact that, there's more or less sensitive people, but we'll see overall in general, how does the independent variable and the dependent variable relate? What are some other sources of variability?
Last time we talked about if the participant is distracted or not.
Yeah, totally. Attention, right? If you're not paying attention, you can miss something that's right in front of your face. You've probably experienced this in life. So, so we need to make sure that that's part of the procedure, that that we make sure that there is this sustained attention. So when the little electrical pulse comes across their skin, they're ready to notice it if they can. So we talk about creating that window where it's sometime in the next 5-10 seconds, get ready. You don't want to say now, because then that's another confound. Like you might just kind of conflate the word now with feeling something. But you want to have some little window where they can pay attention and hold that attention. Right. There are whole, mind wandering is actually something people study a bunch in kind of the science of nervous system and attention and everything. That's actually a term. If you like look it up, there's a lot of like papers that explore mind wandering. It's something we do as humans. Like if you just kind of wait a few moments, no matter who you are, your mind's going to start taking a little sojourn someplace. So we need to kind of control for that. What other sources of variability?
What about like hyperattention, like people that are so like maybe like anxious or something about getting an electrical stim that they'll like feel something when it's not happening?
So that's huge. That's huge. So false positives. So the fact is, so like the analogy I tend to use here is, this actually what does a modern radio look like? Good
A
grief.
cell phone.
Yeah, let's say you have a stereo. It's a nice stereo, and it's connected up to some speakers, and there's a volume control. Even if you are not, and let's pretend, actually, records are getting popular again. It's kind of bizarro to me. But let's say you have a record player, but you're not playing a record right now. The needle is not on the record. So there's no signal really. There shouldn't be any music coming out of here. But if you take the volume and you just crank it up higher and higher and higher, there is just this kind of electronic noise in the system. So you'll kind of hear this kind of hiss coming out, this kind of white noise, right? Because if you increase the volume enough, whatever kind of random noise is in the system, you start noticing it as like, oh, there's that. Right? I don't know if this analogy makes any sense to like the modern student. So in your brain, in your nervous system, there is noise. There's lots of electrical noise, little zip, 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 zip. And when you are trying to detect a just noticeable difference, it's basically the same as turning the volume way, way up. Like I'm trying to detect the slightest little signal. So it's like cranking the volume, which means sometimes one of these little like hiccups, this noise in your nervous system, it's like, whoa, I noticed something. But it actually wasn't anything real. It was just like the noise within your own nervous system. And it was something, but it wasn't something external. So it's actually very common to have false positives when you're barely trying to detect something. You don't want to trust that it actually was there. You want to make sure you go back, double check. It's like what we do on this one sometimes is like pretend we're giving them the stimulus when in fact the stimulus is not on. And this is something we can't experience in Zoom, but is really trippy in real life. And it happens all the time where you go in and you click the mouse and say, did you feel that? And it's like, I totally felt that. And it's like, okay, the stimulator was not on. That was all in your head, right? So that happens a lot. So you really want to, control for that by, doing that kind of thing. Give them a fake stimulus and make sure they didn't feel when you didn't give it to them. Continue on a little higher and make sure they still feel it. So you usually want to kind of double check. Don't just trust. Don't just say, oh, they felt it. Let me write down that data and move on. Like if you do that, you're going to run into trouble. The same thing with the 2-point discrimination that we're going to do in a lab pretty soon, where this is somebody's finger. We take these pins and say, can you feel them when they're that far apart? Can you feel 2 when they're that far apart? Can you feel 2? You figure out how close can these be and still notice it's 2 versus 1. Every class we do this, and I'll get people who have these insanely like, oh, I feel that's 2, and I still feel that's 2. And I'll just go in and go like that. No, totally 2. It's like, no, it can't be. It's just 1. Right. So just putting that out there, that is a source of variability when you're trying to get these thresholds. Other sources of variability.
I didn't know if it was legitimate, but I thought maybe age might be a source of variability if like the sensory receptors break down over time or you're
Right. So I would say, as you age, everything kind of gets worse. Like there, you can actually show we're talking about reflexes. It's even once you're past like your late teens, even a lot of the reflexes are never going to be quite as good as they were when you were that like late teens. So there is measurable degradation of your kind of nervous system. However, probably not enough that is going to affect this. And, so we're just going to, I would say that the reality is I could imagine it does influence to some degree, but we're not going to look at it. We'll just look average across many different ages. If we go back, people have been talking about temporal summation in their hypotheses. How might that affect your just procedure, your methods for doing this experiment, taking into account that this is a real thing? Do you want to go like, here's their finger and put the thing there, here's the electrodes, here's the current source. Feel that? Nope. All right, let's crank it a little more. Feel that? Nope. Let's crank a little more. Okay, feel that? Nope. Let's crank a little. Feel that? Yep, I felt it. All right, that's our value. What's the problem with the way, let's say we did it exactly like I just said.
You could get false positive.
I want someone to bring in the idea of temporal summation.
Do you have to just wait long enough?
Yes. If you test it and they don't feel it, you can't just go crank it and try the next value because of temporal summation. You might actually be adding already to a little bit of residual elevation from the last one, right? So you need to make sure, like in our procedure, we make sure you wait at least 30 seconds after you do one test at a value before you try the next higher value to make sure that you don't accidentally start having temporal summation happening. Right? Does that make sense? So yeah, so this lab, it's a fun lab, I think. For the actual like doing the lab, we are gonna actually, I'm gonna show you a video, and I actually would like you to actually record the data as we go. So I'll kind of start it out, but when you're recording data, you typically want to make some little chart, where you can put the data in. And what would a little table or chart look like to record the data for one of, like, let's say we're working on the finger right now. What kind of little chart could I draw that would make it easy to record the data as I'm getting it? I mean, what's
Like on one side, the voltage, and then the other side, if they felt it or not.
so that is not really going to be that helpful, because you'd end up, hold on, I need to power up here. It's not going to give us information we care about. So let's say, and it would be milliamps. Let's say milliamps and felt. I could say 1 milliamp, no. 2 milliamp, no. 3 milliamp, no. 4 milliamp, no. 5 milliamp, yes. This is kind of boring, and it takes up a lot of space and isn't telling me anything that I didn't know. Because if I had 5 milliamps as my threshold, the minimum that I just felt, that implies that I couldn't feel it coming up to there, right? So the only number I actually care about is what was the milliamps that was the one that I just felt it at. So this part, I don't need to record this. You would be doing this as part of the experiment. There, did you feel that at 1 milliamp? Nope. All right, so let's wait 30 seconds. All right, try it now. Did you feel that? Nope. All right, let's wait 30 seconds. Go continue on. All right, did you feel that? Nope. All right, let's just wait 30 seconds. Go on to here. Did you feel that? Nope. All right, let's wait 30 seconds. Go on to here. Do you feel that? It's like, yes, all right, let's record this as my threshold for this particular condition. So does that make sense?
Yeah.
That also kind of gives you a sense, because there were a few people that, like in their objectives, like, how does the milliamp affect the threshold, right? And that doesn't make any sense. The milliamp is the threshold, right? The milliamp is not an independent or dependent variable. It's something you vary to find out what exact magnitude of milliamps across the skin do you need to just barely feel. So back to our little table. If I am, let's say I'm working on the finger, what would my little table look like to record the relevant data?
The frequency of the stimulant.
Yeah, so if I'm looking at my finger, I could say, what is the frequency? And what frequencies are we working with?
5, 10, 25, and 1 hertz.
Right. And actually before that, we also have single, where there's no repetition at all. We had, was it 1? What else did we have?
5, 10, and 25
And again, what is the unit for these?
hertz.
Hertz. Right, so it's something like that. And what would be the thing you're going to record for each of these conditions? What's the actual data that we'll be finding?
The threshold, the milliamps.
Yeah, exactly. What is that threshold for that condition, which is going to be some milliamps, which was, what was the milliamps where they just barely felt it on their finger when the frequency was this, right? So kind of just getting you guys to like think about, like, the more you can organize your data and have it set up like this, the more when you look at it later, it's not like a mess. So any questions about this? So I noticed some people have not put the procedure into their lab book yet. You should make sure it makes way more sense to have the procedure before you start recording data. So if you haven't actually pasted in your procedure, I would put that in there as well before you actually start recording data. But let's take like 5 minutes right now. And what I would like people to do is kind of just make sure their lab book is ready to go. Have the procedure in there, and then be ready to start recording data in like 5 minutes from now. That's right. Hey Siri, 5-minute timer.
Okay, 5 minutes and counting.
Do we need to put like these big pictures in the lab book because we're not actually doing it? It just seems like a waste of paper space.
I would say it's actually pretty important, because like on your lab exam, there'll be questions about the procedure and this and that. And because it's an open lab book, the fact that you're allowed to have that in there, it's probably going to be helping you. All right, that was 5 minutes, according to, we can see.
It's 11:19.
If you've ever, I have been so amused by this little guy. He like talks.
It's 11:19.
It's like ridiculous. So it's 11:19, and we can now look at the actual lab. So let's do this. I'm gonna go to share screen. Here we are, nerve stimulation lab, doing the nerve stimulation lab. So this is where this video is that I'm playing, and it's also going to be where the data spreadsheet is going to be that you can get afterwards. So this is going to be 12 minutes. You'll see what the actual process looks like and actually record the data in your book as we go. So here's Tina and I doing this. All right, so I'm going to be the subject. Here are the electrodes, this little bar electrode. I'm going to get our little conductive gel to make sure there's a good connection between the electrode and my skin. You're just like kind of half of a split pea or something. You don't want too much. It's going to goop everything up, but you want to make sure there's enough so there's a very positive contact between the electrode and your finger, and also it holds it on well. When you do the calf, we actually have little Velcro straps to make sure that the electrode is also firmly pulled against your calf. But for your finger, the gel works great. One of the things, source of variability with finding these sensory thresholds is the fact that you're turning up the volume so high in your nervous system, trying to detect, is there something there or not? That sometimes just the overall noise inside your nervous system might be detected as something real, when in fact it's just this, any kind of, so if you take your stereo and you just turn the volume up as high as you can go, even if there's nothing on the stereo, you'll still like the white noise. Your nervous system's got noise in it as well. And when you are just bringing up the volume, trying to detect, is there just something there? It's pretty common to have these false positives. Like, I think I felt something, when in fact, there wasn't anything at all. So we need to be careful of that. One way we can do that is making sure I'm not expecting something. So I'm not looking at the screen. I don't know exactly when she is gonna turn the stimulus on.
And I'm gonna do some decoy clicking too.
Right, it's pretty funny when people feel things when there's nothing there, but it's actually just normal.
All right.
Also means when I feel it, she can check a little higher, make sure I still feel it. Or don't, again, decoy clicking. She's not actually giving me any real voltage or current, but see, maybe I'll feel it anyway.
So we're going to start off with a single stimulus. So I have the monitor set at 1 milliamp, and the max repeat rate is 0.1 hertz, which means that it's going to send out 1 impulse per 10 seconds. So, of course, I don't want him to hear me go click on. And so first, I'll just kind of click outside the box, and then eventually I'll click on, and we'll see if he feels it.
I say another source of variability is just mind wandering. So, even if there's something you might notice and you're just thinking about something else, you might not notice it actually because you're thinking of something else, your attention's someplace else. So you probably want to give your subject a window, like, kind of get ready, like in the next 5 seconds, it's going to happen. I don't know exactly when, so I can't just say, oh, that click must have been something. But you want to give your subject a heads up that in the near future, something's going to happen, if it's going to happen.
All right. So you didn't feel anything, right?
I did not.
So then I'm gonna crank it up 0.2 and milliamps. And then we're gonna say, so we're gonna get ready to start soon. So you let me know if you feel anything, David.
Right, so this is at 1.2 milliamps right now for the current.
I did feel something there, actually.
All right, so 1.2 milliamps is what I'm gonna write down in my notebook for this, for the single stimulus for the finger. All right, and then as we move on to the multiple stimulus, we're gonna subtract 0.6 from this number as a starting point. So we make sure that he doesn't feel it. You wanna add anything?
Yeah, so we are trying to like speed this up for you all so you're not like getting bored watching us just sit around and wait. But in reality, if we're going to control for temporal summation, we want to make sure that we don't give one stimulus too quick following a previous stimulus. So when you're doing this experiment for real, you want to wait at least 30 seconds after you give an initial stimulus. If they don't feel it, you just get to sit around for 30 seconds before you go at the next level up. So it ends up being a pretty, this is a lab where people often finally get to know each other and get to know more about each other's lives, because there's a lot of time to kind of sit around while you're waiting in between each stimulus.
All right, so since we're moving on to multiple stimulation and we're gonna change the hertz. So this time I'm moving it to 1.0. And if you have any trouble with the decimal point, you can just use the keyboard on the numbers here and type it in. Sometimes it wants to do something that you don't want to do. And so right now I just typed in 1.0. So hertz, 1.0 hertz, and now I'm going to subtract 0.6. So since his last trial, we wrote down 1.2, it's going to be 0.6.
0.6 milliamps
for the milliamps.
Yes. All right, so are you ready to start?
I am ready.
All right, I'm going to start soon. Nothing?
Nothing.
All right, so now I'm going to add 0.2. So I'm going to change that to 0.8 milliamps. Are you ready to start?
I'm ready.
And you didn't feel anything, so we're going to change that, right?
Yep.
All right, so next one is going to be 1.0 milliamps. And are you ready to start?
Mhm.
You didn't feel anything?
I don't think so. I mean, it's kind of funny. It's like I kind of feel some tingling, but even when nothing's happening, I kind of feel my finger.
All
So
right, so
I
maybe
don't-
we'll crank up one
Yeah,
more and check,
yeah.
and then we can always go back and check it
Yeah.
down. All right, so I'm gonna up it to 1.2. And are you ready?
Mhm. It's hard to know.
Maybe?
I'd say yeah, but I keep going up because
All right.
it's not definitive.
All right, so we're gonna up it to 1.4. All right, are you ready?
Mhm. I found something.
All right, so definitely 1.4. I'm gonna go back to 1.2 and see if you think. Ready?
So there, I do feel something there.
All right,
Yeah, because it's, but you feel it kind of go z, z, z. It's not as.
so
Yeah.
we'll write down
Yeah.
1.2 in our
Yeah.
notebook for that.
Yeah, no, that's interesting because I wasn't sure whether it was just my finger feeling all vibrating, but it was actually,
Okay,
once I really thought about, oh, 1 hertz. It is kind of like that.
all right.
Cool.
All right, so next is we're gonna up the hertz to 5 hertz. And then we're gonna subtract 0.6 from 1.2. So we're gonna start kind of where we started last time, 0.6.
And I should mention, why are we subtracting to start each next trial again? Why are we subtracting to figure out what milliamps should we start for the new trial at the higher frequency?
To account for temporal summation.
Right, because in our hypothesis, we're assuming that it's probably lower, this inverse relationship between frequency and threshold. So we're assuming it's going to be lower than what I just felt it at this previous frequency. So we need to lower it so we're below threshold at this new setting. So just through trial and error of doing this experiment many times, we figured out subtracting about 0.6 usually is good to get you down to a place where you won't feel it. If you did feel it though, that means you'd have to actually lower it even more, because that means we're actually still above threshold.
You ready? All right. Nothing? All right, so I'm gonna up it. And normally you would wait 30 seconds between these trials. So we're trying 0.8. Are you ready? Mhm. Nothing. So we're gonna up it to 1.0. All right, you ready?
I do feel some tingling in there.
All right, so then we would record 1.0 milliamps for the 5 hertz, and then we're gonna up it to 10 hertz. And we're gonna subtract 0.6 from the 1, and so we can need 0.4. All right, so you're ready? Okay. Nothing. All right, so go 0.6. And we'll start. Nothing. All right, go to 0.8. Nothing?
No.
All right, we'll go to 1.0. Start.
Oh, that's definitely a tingling there.
All right, so we will record 1.0, and then we're gonna up the hertz to 25 hertz. And we're gonna subtract 0.6 from the 1, so we're down to 0.4. That's our starting. So you ready? All right. Nothing?
Nothing.
All right. Move up to 0.6. Start. Nothing. Okay. Going up to 0.8. Nothing. All right. And 1.
Yes, I definitely feel something there.
All right. So we will record 1.0 for the last on the fingers. All right.
And then obviously any one individual subject has their data, but to really look for overall trends, you have to kind of average across many subjects, and you'll be getting a spreadsheet with the results from many subjects and look at on average, what do we find? You know, it's interesting to look at an individual, but that's never going to tell you like the complete story.
All right.
All right. So does that give you a good, pretty good sense of what the procedure is like? So are the results from me consistent with the hypotheses that people have been talking about so far?
No, not really.
What's that?
Not really. I thought that for the higher frequencies, the threshold and would change, but it stayed the same for 5, 10, and 25.
Right. So, but we did, it's still, it was monotonically decreasing. We could say that as the frequency got higher, the threshold was either the same or less than what it was at the lower frequency. So in general, what we saw, and again, this data is me in particular, and actually with the procedure a little off because, you know, she was not waiting the 30 seconds that we normally would do. So that would probably affect things. But the fact is, whenever you look at one person, you might actually get data that is not consistent exactly with your hypothesis. To really draw conclusions about, in general, what would you expect? You're going to have to look at a lot of subjects and say, across a lot of subjects, what are the general trends we find? So to do that, that's where we have, I'm going to click right now on this, you know, spreadsheet here, electrical stimulation, fall 19. Open this puppy up. So here is the data from a bunch of different subjects. This is the subject in green here. This is the average. And actually now, if you take a look here, you can see like, oh, as frequency was going up, on average across all the subjects, threshold was going down. In fact, if we look at fingers and we look at, it should say threshold, shouldn't say voltage, it's just say threshold current. I will fix that. Enable editing. I will fix that and re-upload it for you all. This should rid of that. It's because in the old days we used to actually use voltages. So here, this actually does look pretty good, right? Here we're seeing in general, as the frequency went up, thresholds coming down. You know, and we did not show the video of it, but the calf is the same thing. For the calf, you do the same procedure, except the little electrode is on the back of your leg, the back of your calf. And if we look at here, again, this should say threshold, this shouldn't say voltage. The threshold here, as the frequency goes up, we can see threshold coming down. So this is also very consistent with the hypotheses we've been talking about. So does our data support our hypotheses as far as frequency versus threshold?
Yes.
Yeah, and we have two demonstrations of it. We see it's true both on the finger and on the calf. It's not about where we are, it's just in general. If we vary frequency, no matter where we're looking, the relative threshold is going to be lower as the frequency goes up. So what is the other thing we need to look at to see if our other part of our hypothesis is supported?
The threshold for the body part?
Yeah, exactly. We have to look at the threshold and compare against different body parts. So And here, if you take a look, whether it's for single, the 0 is just means single. We only needed 1.8 on average to feel on the finger. But for a single, it was like twice as much current to just barely feel something when we're on the calf here, right? Right, so I could do like compare single here, like what was the perceptual threshold we needed to just feel it on the fingers? It's like half of what it was for what we barely needed to feel on the calf. So this would be evidence for the other part of our hypothesis here, right? So when you are looking at this data, when you are integrating this into your discussion, make sure that you are using the data to support both parts of your hypothesis, because we have data here that can look both at body part versus threshold as well as frequency versus threshold. So are there any questions about this? Whoops, this is supposed to be there. Is this all pretty clear? Right, so in your write-up, you are just going to, you have your original data, so you can talk about what does it look like with just the first person, but then more importantly, when you look at all the data as a group of a bunch of subjects, what do we see and how does it relate to your hypotheses and ultimately your objective? What does the data have to say about your original question about these relationships between the independent variables and the dependent variable? And obviously you'll write that up, and after you do that, there is just yet another submit PDF of complete lab write-up. So, and I am hopefully over this weekend, I'll start getting caught up on grading your other, I know people have turned stuff in and I haven't given as much feedback as I would have liked at this point. But yeah, keeping up on these write-ups is going to make your life way easier as we go on. We're going to be having our lab exam coming up, in a few weeks. And the more you kind of keep up on things, the more you're just going to be ready to take the lab exam when it comes. So let me stop sharing here. Any questions about the nerve stimulation lab? I think it's a nice one. It kind of shows a variety of concepts, kind of demonstrates this idea of temporal summation more in a real world, kind of starts getting a little more at what is perception. And we'll talk a lot more about perception as we continue on.